In this video, you'll learn how to add and subtract radical expressions. If you're following along in your notes, write this in the table of contents with the appropriate page number. Alright, let's get started. By the end of this video, you should be able to say that you can add or subtract radical expressions. In order to do that, you need to know these three things. You need to be able to recognize like and unlike radical terms. You need to be able to simplify radical terms. And you need to be able to combine like terms. So the first part is being able to identify whether terms have like radicands, right? You are like terms if the number underneath the radical sign matches. Those are the radicands. The number outside of the radical sign is called the coefficient. I'm going to be talking about this number a few times during the video, so remember that is called the coefficient. The coefficients do not need to match. You are a like term if you have matching radical terms, right? Matching radicands. If the radicands don't match, then they're not alike. You cannot add them, you cannot subtract them. Even if the coefficients match, that's not good enough. To be like terms means that you have to have matching radicands. All right, so if I ask you to add these two expressions here, 4 square roots of 3 plus 7 square roots of 12, the first thing you should think when you see it is, oh, I can't add those because they don't have matching radicands. And then what we're going to do from there is ask ourselves, is there any way I can modify one of these expressions so that they do have matching radicands? Kind of like when you have fractions, right? If I had 4/3 and I wanted to add it with 7/12, it doesn't mean that it's not addable, just not in its current state, right? You can add them if they had matching denominators, and the same is true with radicals. You can add them if they have matching radicals. So we're going to practice renaming one of our radical expressions today. And we're going to do that by writing a radicand as a set of factors. Now remember, when you break your radicand up into some factors, you need to use a perfect square factor. So 4 is a perfect square, and that means I can take the square root of it. And 3 is not. So I'm going to leave the 3 underneath the radical sign, but my 4, when it gets square rooted, becomes a coefficient. So the 4 turns into a 2. And when 2, which is your new coefficient, comes outside and joins 7, which is your original coefficient, those two numbers multiply together. So our new expression here will be 7 times 2, which is 14, and our radical changes to 3. So 14 square roots of 3 is what I can rename that expression as. And 4 square roots of 3 and plus 14 square roots of 3 can be computed. Now I went through all that work to make those radicands match. So my answer will keep that radicand. So 4 plus 14 is 18. 18 square roots of 3 is your final answer. Let's take a look at another example. Now, before we get into the adding, you really have to perfect your skill of renaming. So remember when you have an expression, you want to factor the radicand by using one of these or more. There's more. I just put the first 15 here because we're going to be working with some relatively small numbers today. But you want to use one of these numbers as your factors. Now, our original question was the square root of 20. So I'm looking for factors have to be less than what you are, right? If factors are numbers that multiply together to become that number, so it has to be something smaller than 20. Now, I know it seems a little ridiculous for me to say, well, you should practice, dividing 20 by all of these factors, right? 20 divided by 16, 20 divided by 9, 20 divided by 4, and you go down the list, so on and so forth. But the more you work with these, the easier it will be for you to kind of guess the right factor. Now the problem is, a lot of times you want to use the factor of 4 when there is something larger. Now for this case, 4 is the largest factor. So the square root of 20 can be written as 4 times 5. 4 is a perfect square, so the 4 comes out as a 2, and the 2 multiplies the 8, which was already outside as a coefficient. So the old coefficient times the new coefficient, and that's how you get your final answer. So again, when you're renaming, you may need to use your calculator to divide by all the perfect squares until you find one that gives you a whole number answer. So 90 divided by 9 will give me a whole number answer, which is 10. So 9 times 10 is 90. 10 is not square rootable, but 9 is. And when 9 is square rooted, out comes a 3. 3 times 7 is 21, and that's how you get your final answer. All right, one more. 6 square roots of 48. Again, I go through my list of perfect squares. I start with the numbers closest to 48, so that would be 36, 25, 16, etc. So 16 worked, so 16 times 3 makes 48. The square root of 16 is 4, and our new coefficient is 24. All right, I think you're catching on, so why don't you pause the video and try these 4 on your own. Okay, let's see how you did. Look those over. Great job. If you got any of them wrong, you may need to go back and rewind the video. Now let's move on to the operations. When you're adding radical expressions and the radicands don't match, you need to make them match. So here's a little trick. If I want to add these two together, they both have to become the same number. Now the only way I can rename these right now that we're working with is by simplifying. And that means by making it smaller. So there's no way to make this 3 a 12, but there probably is a way to make this 12 a 3. So that's what I want you to focus on. Whatever the smaller radicand is, that's what you want them both to become. And what that means is your radical sign has to have a 3 underneath it. So if it has to have a 3 underneath it, then one of our factors should be 3. And that's going to help us to find our other factor. Now this is a small number, so it's fairly easy, but I would pick up my calculator and do 12 divided by 3, and that will give me my other factor. So for us, 4 is pretty simple, but let's say it was a 36. That was something we couldn't mentally figure out. So the square root of 4 is 2, so the 2 comes out. There is no coefficient. There's no coefficient out here. So 2 becomes the only coefficient. Right? This becomes a 2. This becomes a 2, and the square root of 3 remains. Now look what happens here. My radical stays the same. Only the coefficients are added. Okay, this one's a pretty big number, but do you remember what my hint was? If you need them to match, then that means one of your factors for 245 should be 5, because that's what you're looking for as your leftover. So 245 divided by 5 is 49. Square root of 49 is 7. And that 7 comes out and multiplies the coefficient that's already there, which is where I got that 28 from. 7 minus 28 is negative 21. All right, I think you've got the hang of it, so pause the video now and try these last 4 questions. Good luck. All right, it's time to check your work. How did you do? Hopefully you got them all right. If not, you may need to rewind the video a bit and listen again to what my trick is for simplifying your radical, right? Simplifying your radical, the trick is to use the other radical as one of your factors. All right, that concludes our lesson on adding and subtracting radical expressions.